Welcome back, grade 12, to our review. Now let's continue with it. We're on question 5 right now. We're dealing with functions. So here it is said that the graphs of f being negative 1 over 2 into x minus 1 all squared plus 8. So here we're given a parabola, and it is given in terms of the equation that gives us the coordinates of the turning points here. Okay, so in this case, we know that this value here of 1 represents the x value of the turning point, and this 8 here represents the y value of the turning point. So now, since here in the bracket we have a minus 1, we know that we can interpret that as a positive. Even with the sketch, you can see that here the values of the turning point is in the positive. So this is a positive 1 when you write it out. Okay, and we're also told that g of x, well, in this case, we don't have the value of d up there, but we know that this is a hyperbola with this, the x and y, being the asymptotes of the function. Okay, so now they're saying a point of intersection of f and g is b, right up here, the turning point of f. So this is a point of intersection and as well as the turning point. And now we are told that the graph of f has intercept at -3 and 0, 5 and 0. And the y-intercept is at c, like that, as we can see. Okay. So now let's find out what they want in the first place. So they say write down the coordinates of the turning point of f. In the case that they say write down, well, we know that this is information that we can extract from either the given statement or the diagram itself. So here we've been told that B is the turning point, and we know that this formula is in terms of the turning point. And now we can extract that information from up there. Okay, so for 5.1, we can say B, the x value will be a positive 1 and the y value will be a positive 8, as I have mentioned before, right? So we had that negative in there, but we know that when the equation comes with this negative, okay? So now when we have negative and we just have a 1 right there, it means that the 1 came in as a positive number. Otherwise, if this was a plus, it means that the 1 also came with its own negative, which would be negative times negative, giving us that positive right there. So hopefully that makes sense, okay? So let us go on. So question 2 here says, calculate the coordinates of C. Calculate the coordinates of C. Okay, so we know that that's the y-intercept right there. So whenever we're dealing with the y-intercept, we know that the value of x is going to be 0 like that. So we can substitute in 0 here, minus 1, all squared, and we have a plus 8 like that. Okay. So now, if you punch this into your calculator, well, you can see that 0 minus 1 will give us -1. -1 squared is positive 1. Positive 1 multiplied by -0.5, that would give us -0.5. And -0.5 plus 8 should give us 7.5, which is the same as 15/2. So here they did not say calculate the value of y there. They said they want their coordinates, so we have to represent that in terms of coordinates. So therefore, C will be 0 and 15/2, like that. Okay. So now they want us to calculate the value of D. They want us to calculate the value of D. Now, remember that B here is a point that lies on the graph, right, of G. So we can use this point to solve for D like that. So here, remember, we had y is equals to D over x. And let's just move on a bit here. So what is the y value? The y value will be 8. So let me just write here, using B, which is 1 and 8, you can see that D here, now anything divided by 1 is that, therefore, the value of D is equals to 8, like that. Okay. So now here they say, write down the range of G. Write down the range of G. We know that the range represents or refers to the Y values that are used by the graph. So now we see that the graph uses every Y value going up and going down besides the x-axis where Y is equals to 0 there. So someone could choose to write Y is not equal to 0, saying that it uses every other Y value, right? But not 0. Okay. And someone else could choose to write it in this form like here. So Y is an element starting from negative infinity going up to 0. We don't include this 0 union, and we start from 0 again. We don't include the 0, and we go up to positive infinity like that. Okay. So we cannot include infinity because we are not referring to a number like there. It's just referring to a place up there, right? A very large number. So we can think of it as a place rather than a number. And here 0 cannot be included because that is the asymptote. So you can write it like this or like that. Let us look at 5.5 here. So now they're saying for which values of x will f of x multiplied by g of x give us 0 or a negative number, because it's less than or equal to 0, isn't it? Okay, so now how could you read this piece of information? So here they're saying, if I take a y value, remember f of x is a y value, right? If I take a y value of f and I multiplied it with a y value of g, I want those two y values to give me either a negative number or what? Or a 0 like that. So what does this mean? It means that, let me just change the pen here quickly. It means that it's either, I'm just going to do it for the negatives for now, right? It's either f of x is positive or g of x is negative. Because when it's like this, I know that plus multiplied by negative, this should give us a negative, isn't it? Or I could look for a place where f of x is negative and g of x is positive, because now I know that negative multiplied by positive will give me a less than. So this is when I'm considering the less than part. Other than that, you know that either one of them must be 0 so that the 0 is included there, right? So it's either 0 or positive multiplied by 0 or negative, right? So here we are taking care of both cases. Or you're saying this is 0 and negative multiplied by 0 or positive. So in this case, when you say negative multiplied by 0, definitely you're going to get the part where it's 0, isn't it? Or when you say 0 multiplied by positive, you're going to get the part where it's positive. Or in the case where they're both 0, meaning that they share an x-intercept, then 0 multiplied by 0 would give you that 0 as well. So now we have to go back to the function and analyze where this happens. So how are we going to analyze this information? We're going to check where the functions change sign, where the y values become positive and where the y values become negative, right? And we can draw dotted lines there. So you see right here at 5. Here at 5, the y value of the function f of x is 0, isn't it? And if I go north of 5, up of 5, then I see that the y value becomes positive. And if I go south of 5, I see that the function is now what? Negative. So it means this is where the y values change. So I'm just going to draw a dotted line like that. Just going to draw. This is for the purposes of analysis, right? And the same thing happens this side with the negative 3. So I can draw that dotted line again here. Remember that this is not an asymptote. It's just a way that will help me. I'm dividing the graph or the graphs into certain parts where it changes, right? Where the function stops being positive and starts being negative and so on. So now this allows me to analyze the graph. So I want you to notice as well I want you to notice something. G of x, when I am this side of 0, right? When I'm on the right-hand side of 0, G of x will always be a positive function. Okay, so let me just use this pen here. I will use blue. So it means that this function is always positive. So between 0 and 5, the function of g is positive. And after 5, the function remains positive as well. And I could go again, analyze this part. Well, the function between 0 and -3, the function is always negative. And even after -3, the function is like still what? Negative like that. So this function here is easily seen where it's positive and where it is negative. And I will use a red pen here to analyze where the function of f changes, right? So you see that when I'm this side, when I am less than -3, the function of f is negative, right? So it's negative here, it's negative everywhere. Just if I go less than -3. And when I go north of -3, when I go north of -3, I see that the function right here is what? Is positive. Okay, so that function is positive right there. So maybe I should also highlight the asymptote because at 0, there's no function. So let me just highlight the asymptote as well. Okay, I'm just highlighting the asymptote of g right there because this also divides the plane, right? Because this arm only exists, this side does not touch 0, and this arm only exists on the right, does not touch 0 as well. So hopefully that will help us in our analysis. Okay, let's go on with checking. So now between 0 and 5, I also see that my function of f is what? Happens to be positive. So it's positive everywhere from starting from -3 going to +5. And this is true because the graph is found above the x-axis. And when you go on the right of +5, then I see that the function is what? Is now negative. Now let us go back to our conditions down there. We said that we want it such that it is less than or equal to 0. So where either function is either negative, positive, or positive, negative. And we can also include 0 because it is also included there. Right. Now, I see that my f of x, is 0 at 5, right? It's 0 at 5. And when I go to this side, then g of x is positive and f of x is negative. So this part satisfies the condition because when I multiply a y value from this portion with a y value from that portion, I will definitely get a negative answer. So now, how do we include the 0? Well, it means that we will start from that positive 5 right there. So the value of 5 is included. If we wanted values that are strictly less than 0, meaning f of x multiplied by g of x is less than 0, it means we wouldn't include the 5 there. Because when I include the x value equal to 5, I'm also including the y value being equal to 0 right there. So we're not going to include that value there. Okay? So we have found the first part. And now let's analyze again here. In between 0 and +5, I see that both functions are positive. So I'm not looking at that part. And now let's check this part here. Between 0 and -3, I see that f of x is now positive and g of x is what? Is negative. So between these two values here, okay, the function, this one is positive, this one is negative. So it satisfies the condition, right? So now I will start from -3, right? And means I'm going towards what? I'm going towards 0. But then I cannot include the value 0, the x value close to 0 here. Why? Because the other function does not exist. Remember that 0 is the asymptote of g. So we are approaching 0, but we'll never touch the value of 0 right there. So now we can report this interval in our final answer. So this is how we're going to do it. Okay. Okay. So therefore here, let's just report the information. So we're starting from -3. We have to include the -3, right? So I must use a square bracket here. So I include -3 because when x is -3, the function is 0 and 0 is included, isn't it? And I go on to where? To 0, but I'm not going to include 0 because one of the functions does not exist when x is equals to 0. And union, now I'm going to include the other part of the interval, which is, I can say, starting from +5, 5 is included because at 5, one of the functions is 0. And this goes on to where? To +infinity. And I do not include that +infinity. And that's how you will analyze 5.5. Okay, let us go on to 5.6. 5.6, they're saying calculate the values of k so that h of x is equal to -2x plus k will not intersect with the graph of the graph of g. Okay, so let's just go up there, right? So the graph of g is the hyperbola, right? The graph of g is the hyperbola. So let me just change color here. I might just use, let's just check how pink looks. Right. Okay. So now they're saying that this function of h should never intersect, right? Should not intersect with the graph of g. So meaning that the graph we're going to draw cannot be here, right? Cannot be above, cannot go this side. Okay, because in that case, it would intersect with the function twice. Okay, and the function cannot be below the sign because it would intersect with the function twice. So this means that it must be between the arms like that. So this means that it must be between the arms. Okay, so in that case, let me check. Yeah, so it means that the function must be between the arms, where the upper limit will be what? When the function is a tangent. So we need to find the upper limit here that is allowed. Not strictly allowed, but the one that we're going to use to calculate is when the function is a tangent to the graph right there. Then here it means that we're going to find the value of k. We can call this k max, right? And we know that the function should just exist below k max. And the function should also be a tangent at the bottom right there. So where this is going to be k minimum, right? Now, the diagram looks in this fashion because I know that my gradient that I was given is -2 like that. Okay, so when the function is a tangent to the graph here, right here, let's call this point, let's call this point Q, and we'll call this one right there at the bottom point G. I know that the function, whatever function we're going to draw, right, its value of k must exist between k max and k minimum without having to touch these values of k there. Okay, so now what is the final restriction? It means that I have to find what is the tangent, what is k max if I allow h of x to be a tangent. And then I will also have to find k minimum if I allow h of x to be a tangent at g, like that. And then we'll find the values of k which are permitted, such that they will never intersect. Okay, so how are we going to find these values? Right. Remember that anytime we're dealing with tangent, it means that derivatives must play a role. Okay, so it means that we are going to first derive. Okay, so we have 5.6. Remember that h of x is equals to negative 2x plus some k right there, isn't it? Okay, remember that this negative 2 here represents the what? The gradient. So it means that we have to derive the function of g and find the x values, which will give us a gradient of negative 2. Then we can use that piece of information to solve for the values of k, where h of x would be a tangent to the function of g. So let us go on. We know that g is equals to 8 over x. So this means that this can also be written as 8 to the power negative 1 like that, isn't it? This makes our lives easier when we want to take the first derivative, which will help us obtain the gradient. So when I look for the first derivative, I am going to get negative 8 and negative 1. This will give us negative 2. So it means that our function g of x prime, or our first derivative, is negative a times x to the power negative 2 there. So now we need to find out, when will this, remember that the first derivative helps us to get the gradient of the tangent, or the gradient along the function at any point, isn't it? So now we need to find out which x value will give us a gradient of what? Of negative 2. This is when we are going to find out and treat h of x as a tangent to the function, isn't it? So now we're going to have negative 2 there is equal to negative 8 x to the power negative 2. So maybe I could just write it like this. Instead of writing it like that, let me just write it like this. So let me just have my x squared right there. Okay. And now I'll multiply both sides by x squared. So I'm going to have negative 2x squared equals to negative 8 divided both sides by the negative 2. Then I get that x squared is equals to a positive 4. Then when I take the root of both sides, then I have my values of x, which will be plus or minus 2. So let's go up there to our functions. So it means that if h of x were to become a tangent to this function of g, it would happen where? At negative 2, or it would happen at positive 2 like that, isn't it? So now we need to find the y values. So that we can substitute into h of x, so that we can look for the value of k. So now we need the full coordinate of q, and we also need the full coordinate of g. So going back down there, if I substitute for g is equals to minus 2, this is 8 over negative 2. This gives me a negative 4. So it means that if the point that I labeled as g, it would be negative 2 and negative 4, right? And if I substitute in for g is equals to positive 2, this is 8 over 2, giving us a positive 4. So it means that the point that I've labeled as q will have the coordinates 2 and 4. And now these 2 points here, these 2 coordinates can help us find the value of k. So now, if I'm looking for k max, remember that if I'm looking for k max, I would use this point here. And if I'm looking for k minimum, I would use that point there, isn't it? So let's do that. So remember that h of x is equals to negative 2x plus k. So this would be negative 4 right here. Let's just find minimum first. So negative 4 equals to negative 2 and negative 2, and we can solve for k right there. So now this will be a positive 4. Positive 4 goes to that side. This becomes a what? A negative 8. So it means that K minimum will be negative 8. Well, since it is symmetric, then we know that K maximum should be a positive 8. But then let's go on and solve for it. So if I substitute a positive 4 equals to 2, it's negative 2 into positive 2 plus K. Here we're solving for K max. Then this would be a negative 4. Negative 4 goes that side, becomes a positive 4. 4 plus 4 gives us positive 8. So this would be K max like that. So now the value of K such that it should not intersect the function of G should exist between K min and K max. So therefore, K should be a value between positive 8 and negative 8. We cannot include the values of negative and positive 8 because if we do, then we are saying that it is allowed to be a tangent at those points there. And that's how we would solve this question. Very nice. It needs a bit of analysis, but it's, yeah, I would definitely say it's a nice and easy question like that. Okay, let us go on to 5.7. They're saying that H is a tangent. Surely they're referring to this H that we've been dealing with up here. So now if H is a tangent, it means that the value of K will either be negative 8 or it will be positive 8. We'll just see in a moment which side we'll be working with. So now to G at R, okay. So point R in this case could be the ones that we've labeled either as G or Q. In the first quadrant, so now we know that R will take on the values that Q has, right? Now they say calculate T such that Y equals to f of x plus T intersects G at R. So meaning that by how much have they increased, decreased the function, right? Such that it intersects the function of G at that point. So now let's go up right here. We know that Q in this case now has become R, right? And we know that the coordinates right there are 2 and 4. So now you see that the function has to decrease, right? Has to move down in order for the function to intersect the function of G at that point. So probably maybe it could look something like that. So it has decreased by some amount. We're not sure by how much. We're just going to find that out, right? And maybe the function touches them. It's just a sketch, okay? So you'll forgive my artistic drawings right there. Okay, so now we need to know by how much has decreased from there going there. Well, we know that that's the value of T that we're trying to solve for in this case, isn't it? Yes. Okay, so now let us go on and write it out. Let's go on and write it out and see how we can easily solve this question. So I think here the part that could have been tricky was to analyze, right? So in this case, remember that H has been given, we have solved for H before, and then we are taking it to the next question, and we need to use that information right there. So now, of course, we know that H of x is equal to negative 2x. So since we know that it touches the point in the first quadrant, so this becomes a positive 8 like that. And this means that R will have 2 and 4, right? Then R becomes 2 and 4. Okay, so now if the two functions are going to intersect, okay, if the two functions are going to intersect, it means that their y values are going to be the same at that point, isn't it? So now y is going to be equals to g of x. Remember that y is equals to f of x plus t is equals to g of x, right? Yes. Okay. And now these two functions are going to be equal, right? But then now already we have a point where they're going to meet. We have point R. So it means that they're going to meet when the when the x value is 2, when the x value is 2, or when the y value is 4, right? Or when the y value is 4. So now, what is the equation for f of x? Remember that f of x is negative 1 over 2 x minus 1 all squared now, or plus 8, and then we have to add plus t now, which is going to be equal to, what is g of x? It's just 8 over x, like that. Okay, so now we don't need to complicate our lives. We already have an x value where they're going to meet, because we know r right there. So we can do that quickly. We can say, well, negative half into 2 minus 1 all squared plus 8 plus t equals to 8 over 2. So now I could take everything to other side. Well, let's just first simplify this. What are we going to have here? We're going to have t. This guy here, 8 over 2 is going to become 4, right? And what are we going to have here? We're going to have, this is going to be positive. 2 minus 1 is 1. 1 squared is 1. Then you have 1 multiplied by negative half. Negative half. Take negative half to that side, becomes positive half. Then 8 goes to the other side as well, so it's negative 8. And you see that you're going to end up with 4.5 minus 8, which is 3. Negative 3.5 can be written as negative 7 over 2. So therefore, the value of t is negative 7 over 2. Well, thank you for joining in on the review, and I will see you on the next one. Cheers.